Hello everyone, and welcome to this edition of Fast Track for Azure Learn Live. My name is Nicholas McCullum. I'm a principal engineer on the Fast Track for Azure team here at Microsoft. Our topic for today is Integration Service Environment to Logic App Standard Migration Revisited. We originally recorded this session back in July of last year, but due to a number of bug fixes and feature changes that have been made to the migration tooling since then, we thought it would be a good idea to re-record this session so that you have the latest information to help you successfully migrate your Logic apps from ISE to Logic App Standard. A Learn collection has been created to accompany this video that includes interactive learning exercises, video. In this session, we will review the process for migrating an integration service environment to Logic App Standard. As a reminder, Integration Service Environment will retire on August 31st of 2024. After that date, customers will no longer have access to their deployed ISE instances, and any workflows that are running on those instances will no longer be executed, and any run history associated with those workflows will also be removed. Any integration account that's associated to an ISE instance will also be removed. A set of tools has been created for Visual Studio Code to assist you in migrating your integration service environment to Logic App Standard. These tools will assist you with the following steps in your migration: exporting your existing workflows from an ISE to a Logic App Standard project, running, testing, and debugging your migrated workflows locally, and deploying your migrated workflows to Azure. This session is intended for customers who have existing integration service environments that must be migrated to Logic App Standard before August 31st of 2024. The session materials and the scripts that we will be using during our demonstrations can be found at these locations. We will cover an overview of the migration process, discuss using the Logic App Standard extension for Visual Studio Code, running, testing, and debugging your migrated Logic app locally, migrating an integration account from ISE to another SKU, and then connecting that integration account to a workflow. We will also cover deploying your migrated Logic app to Azure. So let's take a look at the overview of the migration process. So how do I migrate my Logic apps from an integration service environment to Logic App Standard? Well, first we're going to download and install Visual Studio Code. Then we'll install the Logic App Standard extension for Visual Studio Code. We'll look at how do we want to group our Logic apps that we're exporting from our integration service environment into a Logic App Standard project. We'll export the ISE workflows to a local project. We'll then remediate any issues that are identified during the export. And then we'll run, test, and debug our exported workflows locally. And once we're confident that they're working in the manner that we expect, we'll go ahead and deploy them to Azure. In this segment, we will cover installing the tools that are necessary to migrate your Logic apps from Integration Service Environment to Logic Apps Standard. The tools are implemented as an extension for Visual Studio Code. You can download Visual Studio Code from the location here. Once you have installed Visual Studio Code, click the extensions icon in the left-hand menu. In the search bar, type Azure. The first extension we will install is the Azure Account extension. This extension will allow you to sign into your subscription so we can export your logic apps from an integration service environment. Once the Azure account extension has been installed, we want to download and install the Azure Logic Apps standard extension. Type Azure Logic Apps in the search bar to find the extension. There are actually two Azure Logic Apps extensions for Visual Studio Code: the Azure Logic Apps Consumption extension and the Azure Logic Apps Standard extension. For migrating Logic Apps from Integration Service Environment to Logic Apps Standard, we want to use the Azure Logic Apps Standard extension. The Azure Logic Apps Standard extension will install all of the necessary prerequisites for the tool to operate appropriately. Previously, you were required to install all of these prerequisites yourself before installing the extension. Due to the fact that the installer is installing a bunch of additional extensions as well as some runtime components, the setup of this extension may take a few minutes. Once installed, you will be prompted if you want to install all the necessary runtime dependencies needed. Click Yes here. As you can see, additional runtime dependencies such as the Azure Functions runtime and the .NET SDK are being downloaded by the extension. As you can see, the final message basically tells us that the Logic App Standard runtime dependencies have been installed and validated successfully. At this point, the Logic App Standard extension is ready for us to use to begin exporting our Logic apps from Integration Service Environment to Logic App Standard. Now that we have our tools configured in Visual Studio Code, let's walk through exporting a group of Logic apps from an Integration Service Environment to a Logic App Standard project. Here I am in the Azure portal, viewing the Logic Apps blade for one of my Integration Service environments. We'll export several of these Logic apps to a Logic App Standard project. In Visual Studio Code, I select the Azure icon from the left-hand menu to view all the Azure extensions I have loaded. The Resources blade will allow me to view all of the Azure subscriptions I have access to, and I can expand a subscription to see its associated resources. The Workspace blade will allow me to access the Logic App Standard extension, and I can select Export Logic App from the menu to start the export tool. Select your subscription from the drop-down list, and then select your integration service environment. Click Next to continue. The export tool will display the Logic apps from the selected integration service environment. Select one or more Logic apps to export. You will want to put some thought into how you want to group your Logic apps for export, as they will be deployed to the same Logic App Standard host. We will discuss grouping your Logic apps in another segment. Click Next to continue. The export tool will validate the Logic apps you have selected to ensure there are no issues that will prevent the export from succeeding. A green check mark indicates no issues. An orange exclamation point indicates a warning, but the export can proceed, while a red X indicates errors that must be addressed prior to export. You can expand each Logic app to review any of the errors or warnings. In my case, all of the Logic apps pass validation, so I can proceed. Click Export. On the Export page, select the location to export your Logic apps to. We highly recommend that you do not choose to deploy managed connections. The export tool will use the Logic App standard built-in connectors rather than managed connectors during export. The built-in connectors are stored on the host with the workflows and can provide improved performance over managed connectors. The export tool produces a report of items that need to be addressed before the workflows can be deployed to Logic App Standard. In most cases, these items will identify connection information that needs to be updated, but may also include changes that need to be made due to differences in the connectors. Select Export and Finish to continue. When the export completes, the tool opens a new instance of Visual Studio Code, pointing at the folder where you exported the Logic apps. Let's review the project structure that was created by the export tool. The deployment folder within the development folder contains a set of ARM templates that can be used to create a Logic App standard host. This can be useful if you're using an infrastructure as code approach to create your hosting environment. The logs folder contains an export folder that houses the log reports that were produced by the export tool. You can review these reports if you need to be reminded of the changes that were required following export. A folder is created for each Logic app that was included in the export. The connections.json file contains all of the connections used by the workflows. Some of these connections refer to application settings that will need to be configured in the local settings.json file and in Azure as instructed by the export tool output. Let's add the necessary connection information to the local settings.json file. If you don't remember which resources the connections in the workflows refer to, you can return to the Azure portal and look up the connection information from the original Logic apps in your ISE. Select API connections under Settings, and then select the connection. Once you know the name of the resource, you can navigate to that resource in the Azure portal and obtain the connection details. Before we can run, test, and debug our workflows locally, we want to ensure that we will be able to view run history just like we can do in the Azure portal. This step is only required for stateless workflows, but many times people may not remember if a workflow definition is stateful or stateless. So I typically add this setting to the local settings.json file for every workflow. Once this is complete, we are ready to begin running, testing, and debugging our workflows. We'll address any other issues identified by the export tool during this phase. If your ISE contains a significant number of workflows and you would like to validate and export them all in bulk in order to get a bird's eye view of all the issues you may have to address, you can use my bulk validate and export ISE Logic App script that's available here. Once you have the script downloaded, simply execute it and provide your subscription ID, Azure region, resource group name of the integration service environment, and the integration service environment name. The script calls the validate API for each logic app in the ISE, and if validation is successful, it calls the export API on the logic app. Each logic app is exported to a storage account whose URL is provided in the output. No grouping of logic apps is performed, and each logic app is exported into a separate logic app standard project. Now that we've walked through exporting a series of logic apps from an integration service environment to a logic app standard project, let's revisit the topic of grouping logic apps for export. I want to point out two excellent blog posts that address this topic. The first post is by Wagner Silvera from our Logic Apps product group and covers all of the key things to consider when deciding how to group your logic apps for deployment to Logic App Standard. The second post is from my colleague and fellow Fast Track engineer Ben Gimblett and covers hosting options and performance tips. This is a must-read for anyone working with Logic App Standard. The last item I want to demonstrate related to this topic is a PowerShell script that will list all the connections used by each logic app in an integration service environment. Grouping logic apps that share connections is a key consideration in this exercise. This script will extract the data to a CSV file so you can import it into Excel and sort it to determine how to organize logic apps that share connections in your ISE today. Simply provide the script with a subscription ID, the resource group name of the ISE name, and an output path. As you can see, the script lists each logic app in the integration service environment and then the connections that are used by that logic app. This data is again also exported to a CSV file. Once the script completes, open the CSV file in Microsoft Excel. Now that we've completed exporting our logic apps from our integration service environment to a logic app standard project, and updated our connection strings in the local settings.json file, let's run, test, and debug our workflows in order to address any issues that are uncovered. In Visual Studio Code, there are 3 emulators that appear in the notification area: a table storage emulator, a queue storage emulator, and a blob storage emulator. Click on each one of those to start the service so they can be used for debugging purposes. Once the emulators are all running, before we do any debugging, let's quickly take a look at our export report to remind ourselves of any issues that may need to be addressed in the workflows. Now, we've already addressed the issue with the connection string, so we can ignore that. But there's also a step here on line 15 that says there's basically an operation, get blob content v2, that has a path property which references an output from another operation, and that these can't be extracted during export. So we'll probably have to address that. So we'll go ahead and take care of that. There's also an informational message here that tells us, hey, the behavior of some of these operations have changed, so just take a look at that. So let's go ahead, we'll start debugging, and we'll address this issue as well as any of the other issues that might crop up while we run and test these. So let's go ahead and select Run and start debugging here. And we'll notice what we're going to see here is that the Azure Functions runtime is going to spin up because, again, Logic App Standard is now hosted on the Functions runtime. So the Functions core tools are going to start up, and it's going to go ahead and attempt to run all of these workflows in the same manner that it would basically run a set of Azure Functions if we were doing this with Azure Functions. So right away we see, hey, there's an issue with this workflow called copy blob to blob, and it's basically saying we've got an invalid trigger path / SFTP export. Paths must be in the format container / blob. So this is obviously a difference between what we used to have in the connector in ISE and now the Logic App Standard connector. So we'll go ahead and address that. We'll also see that the timer trigger is running here, the workflow dispatcher. That is for list blobs. So let's go ahead. We know that list blobs is actually running. And we'll also notice that there were 2 HTTP trigger fired Logic apps. Those appear to be up and running, and they basically got a URL that we can invoke these from Postman or some other tool if we wanted to. But let's take a look at the list blobs and see what's going on there. So I can expand the list blobs here. I can right click on the workflow.json file and go to overview. And I'm going to see my run history just like I would if I was running in the Azure portal. And I can see they're failing. All right, so they're being executed, but they're not being executed properly. So again, I can click on the run identifier here. And again, I can see, okay, the trigger fired okay, but I got a bad request on list blobs. So let's take a look at that. And I can come down here. Let's see if we can get some kind of a message here. Okay, it says the service provider action failed with an error code that there's an operation ID that's not supported. And it says basically the list blobs from URI is not supported. And then it lists all of the available operations that are supported by the connector. And probably the one that we're looking for is list blobs. So again, there's a difference between the 2 connectors, the one that we used in ISE and the one that we're now using in Logic App Standard. So we need to go ahead and address that. So let's go ahead and do that. I'm going to go ahead and close this out, and we'll just stop debugging for the moment. All right, great. So now we're back here in the file system. Let's right-click on the workflow.json file, and we're going to open the designer. And again, this is the same designer that we're used to seeing when we're doing Logic Apps development in the portal. You know, in some cases, even in older versions of Visual Studio, where we still had the Logic Apps designer. But list blobs here is a problem. You'll notice it's even struggling to open this in the designer because it doesn't know what this operation is. Okay, so let's go ahead and find the correct operation here. So let's add an action. I'm going to do a search for blob. And I'm going to say, okay, Azure Blob Storage. And let's see if we can find this new blob here. List all the blobs using the path. That's probably the one we want on the new connector. So let's go ahead and grab this guy. All right, and then you'll notice it says just give me the name of the container that you're trying to go after. And I believe it was SFTP upload, if I recall. And let's go ahead and back out of this. And we'll save that. And then let's remove this old operation here that it doesn't understand. And again, we'll go ahead and save the workflow. All right. So let's go ahead and close this and let's look at the workflow.json file now. Right. So now we've got the trigger recurrence that's firing every 1 minute. And then we're using this new list all blobs using the path, and the container name we want is SFTP upload. All right, and we're connected to Azure Blob 1 just like we were originally. So let's start the debugger again and see if that's resolved our problem. Again, we see the Azure Functions runtime starting up. Okay, still got an issue with copy blob to blob. We're going to come back to that and address that in just a minute. But let's see if list blobs is now actually executing and returning the appropriate information that we expect. And we can see it's ran a couple instances here. We'll go ahead and let it run one more, and then we'll go ahead and we'll check the output so we can see if what's going on here. All right, let's go back to the overview now. Well, let's check our run history. Now this still says failed, but we're going to give this just a moment, because if we look at this, okay, so it's still showing that we're running list blobs v2, which is the old one. So this is old run history. So we'll just wait a second. We'll refresh this. Okay, so there goes another one. And you'll notice now this one has succeeded. Great. So there's my recurrence. And now we're using list all the blobs using the path. Let's select this and take a look at the output. And there we go. If we look at my output, here is the list of all the blobs in that SFTP upload container, which is what we expect to get back. So we've now addressed the issue with list blobs. Let's go back and take a look at copy blob to blob and address the issues there. So again, let's go ahead and stop the debugger. And we'll close out our run history here for list blobs. We're good with that guy. And let's open this up. All right, so fire up the workflow designer again. All right, so it said, hey, this get blob content has got an issue. Well, if first the functions tool, the runtime threw an issue saying there's something wrong with the trigger, and you've got a bad path here. And it basically said, hey, you should be using container name / blob name. So this used to be an actual path in the previous connector, which is why I had the slash on here. And now all we need to provide is the container name, right? So we're going to remove the slash, go ahead and save this. Okay, so that should address the hard error that's being thrown by the function's runtime. And now let's address the issue that was pointed out in the log report from the export. And it's basically saying, hey, I did the best I could to map the properties from the original ISE workflow to the one in Logic App Standard, but this property here is just not right, right? That doesn't exist. So let me remove this. And what we're trying to get here is the full path to the blob so that we can get the content so we can copy it to another container. So let me remove this, and then we'll use the little lightning bolt, and we'll say, okay, here's the response from the trigger. What do I want from this guy? So I've got the name of the blob, the container name, container properties. This is probably what I'm looking for. The blob full path with the container name. So let's drop that in there. And hopefully that should address the issue that was reported by the export tool. All right. So we've taken care of the hard error that was being produced here because we had a path that it didn't like with the new connector. And we've taken care of the issue here where this blob URI was invalid because the expression was incorrect when it got exported. So let's save this. And now let's go ahead and go back and start the debugger again. And let's just make sure before I do this, let me open this with the designer again and make sure I know where I'm going to upload. Okay, so SFTP export is where I want to upload a new blob to verify that this guy is getting fired. So let's go ahead and start the debugger. And what we should see is the red exception that was being thrown by the function's runtime because it didn't like the value in the trigger should be taken care of now. So, okay, so again, notice that we're good here now. We didn't get a red exception. All 4 of the workflows are now being loaded and are being executed. And we can see right away the one for the timer trigger just fired to list blobs. So let's go ahead and I'm going to upload a blob to that storage account. And then we should see the blob trigger fire for copy blob to blob. So let me go ahead and do that. Just give me 1 second here. Go to my containers. Export. All right, so I'm going to upload a new file here. I've got a couple just CSV files that I'll go ahead and upload one here for us. So let me upload that guy. All right. So we just basically seen it kind of flew by pretty fast, but it picked up that we executed copy blob to blob here. It's seen that come in. So again, very quick. Let's go take a look now and see what happened. Right. So let's go to the overview. And this says it succeeded. So let's take a look. All right. So we've got basically, hey, when a blob is added or modified, and again, we uploaded this SFTP export. All right, great. Let's refresh this. And let's take a look at the create blob here at the bottom. And there's the file, group membership.csv. And it was successfully uploaded to the other blob container, which was SFTP upload. So again, things are working the way we expect it to. Now that we've corrected those couple issues, we can actually go over here and look at list blobs since he is listing the contents of the SFTP upload folder. And we could come down here and look at the raw outputs. And we should see that group membership CSV file in here somewhere if we poke through this output. And I probably went past it. I don't know what order these are being listed in, but it should be listed here now because we have uploaded it to that other folder. Well, let's just do this. Let's just take a quick look in the Azure portal real quick. We'll bring that over here. Yes, there it is, group membership.csv. So there it is. We can see that it got successfully copied. So at this point, we've addressed all of the issues that were covered in the log file from the export. We've also addressed a couple issues that were identified when we went ahead and we started up the debugging session. And at this point, our workflows would be ready basically to deploy to an instance of Logic App Standard in Azure. If you have Logic apps in your integration and service environment that utilize an integration account to perform EDI transactions such as X12, Edifact, or AS2, you will need to migrate your integration account from your ISE to another SKU. Once you have migrated the integration account to a new SKU, you will need to link it to the Logic apps you have exported to a Logic App Standard project. There are two approaches you can take to migrating your integration account. The first approach involves exporting and modifying the ARM template of the original integration account, and the second involves upgrading to the new integration account premium SKU. To redeploy your integration account to a standard SKU via an ARM template, follow these steps. Navigate to the integration account blade of your ISE in the Azure portal and select the integration account that you wish to migrate. Select the Export Template option under Automation. And once the template has been exported, select Download. Edit the template.json file and remove the references to the integration service environment. Make the same changes to the parameters.json file. Once you have completed modifying your ARM template, navigate to the Custom Deployment blade in the Azure portal. Select the Build Your Own Template in the editor link, and then choose Load File to upload your modified template. Click Save to continue. Select a resource group and provide a name for your integration account. Remember that if you're going to deploy to the same Azure region as the original integration account, you will need to select a different integration account name in order to avoid a conflict. Select Review and Create to continue. Click Create to begin the deployment. Once the deployment is completed, we can navigate to the new integration account and verify that all of our agreements, trading partners, schema, etc. are there. If you wish to migrate to the new Premium Integration Account SKU, follow these steps. First, create a new Premium Integration account in the Azure portal. Select Review and Create to create the resource. Click Create to start the deployment. Next, we need to grant the managed identity of the Premium Integration account RBAC access to the storage account that we selected during the creation process. The managed identity of the integration account will need storage account contributor, storage blob data contributor, and storage table data contributor roles. Once the Premium Integration account has been created, return to the Integration Accounts blade of your ISE and select the integration account you wish to migrate. Select Export under the settings to open the Export blade and choose Export Artifacts. Select the Premium Integration account we created earlier and then select OK. Once the export has completed successfully exporting the artifacts, select Export Agreement State. Again, select the Premium Integration account we created earlier. To move all agreements, don't select any options from the drop-down list under Agreement, and everything will get migrated. Select OK to continue. Now that everything has been exported, we should be able to go and look at the Premium Integration account, and again, see all the trading agreements and partners and any other resources that were originally associated with the integration account that was in ISE. Once you have migrated your integration accounts to another SKU, you need to link the new integration account to the workflows in your Logic Apps Standard project. To link the integration account, open the local settings.json file and add the workflow integration account callback URL setting. Obtain the callback URL from the integration account in the Azure portal and set the value of the app setting. Open one of the workflows in the Logic Apps Designer that needs to access the integration account. Select one of the actions that needs to access the integration account and change the connection information. Provide a connection name and then place the callback URL in the integration account SAS URL. The integration account ID is the full resource ID of the integration account in Azure. Unfortunately, this value is not available from the Azure portal. We will run the get az resource PowerShell command to obtain this information. Save the changes to the Logic app. Repeat this process for any other workflows in the project that need to access the integration account. Once you have deployed your workflow to Azure, verify that the workflows are successfully executing against the new integration account. Now that we have finished running, testing, and debugging our exported workflows, let's walk through how to deploy them to a Logic App Standard instance in Azure. In Visual Studio Code, review any of the app settings in the local settings.json file that will need to be created in the Logic App Standard instance in Azure. App settings in the local settings.json file are only valid when running your workflows locally, hence the name of the file. If I switch over to the Azure portal, you will see that I've recreated the connection strings and SFTP settings in the app service configuration. Back in Visual Studio Code, I'll select the Azure icon from the left-hand menu to open the installed Azure extensions. From the Workspace blade, I can access the Logic App Standard extension and select Deploy to Logic App from the menu. I select my subscription and then the Logic App Standard instance that I wish to deploy to. Now that the deployment is complete, I can return to the Azure portal and verify the run history on the list blobs workflow. Since this workflow is triggered by a timer trigger, I'll be able to verify that the deployment was successful. Two great features of Logic App Standard is one, that my Logic apps are now source code. I can check these into source control and easily manage them alongside my other application components. And two, since Logic App Standard runs on top of the Azure Functions runtime, I can easily deploy them using the same techniques I use for Azure Functions. Let's switch over to Azure DevOps and examine these features closer. Here I am in Azure DevOps repos, and you can see I have a Logic App Standard project stored in a repository. I have created a simple build and release pipeline using the classic pipeline editor to make it easier for you to visualize the steps in the deployment process. The build pipeline simply takes the source code from the Logic App Standard project and creates a zip archive containing all of the project files, and then sends the archive to the drop location. Let's go ahead and queue this build. Now that the build is completed, let's review the release pipeline. The release pipeline is very simple, as it uses the Azure Functions deployment task to perform a zip file deployment to the Logic App Standard instance, in this case, instance LA2. Let's queue up this release. Once the release completes, let me return to the Azure portal, and again we'll check the run history on list blobs to verify that the deployment worked, again as it is fired by a timer trigger. So as you can see, it is very easy to deploy our workflows to a Logic App Standard instance using either Visual Studio Code or Azure DevOps or any CI/CD tool for that matter that can do a simple zip deployment to an Azure App Service. So just to recap the information that we've covered in these video segments, Integration Service Environment will be retired on August 31st, 2024. Tools have been created for Visual Studio Code to assist you in migrating Logic Apps from ISE to Logic App Standard. Integration accounts that are running in an integration service environment must be migrated to another SKU such as Standard or the new Premium SKU. Hopefully the information provided in these videos will help you get started with migrating your Logic Apps from integration service environment to Logic App Standard. Good luck in your migration efforts.